Are you aware of the fact that death of a star gives rise to the birthplace of a new star?
If not, then we are here to race you along the life of stars.
Let's begin with how stars are formed. Stars are formed inside nebulae. A nebula is a vast cloud of dust and gases. Inside a nebula, the gravity forces the clumps of dust and gases to combine together to form a giant spinning ball, which causes the temperature and pressure to become high enough for nuclear reactions to occur, which begin to radiate energy, and thus a star is born. So can you tell me, what does a star do in order to sustain itself? Well, let's explore.
The fuel for the stars is obtained through nuclear fusion reactions, wherein a hydrogen atom fuses with a deuterium atom under extremely high temperatures and pressures to form helium-3 with the release of a gamma ray. This process emits enormous amounts of heat and light energies. Now let's see how this energy affects a star's physical shape.
Gravitational forces within a star try to contract it, while the heat emitted tries to expand it. These forces counterbalance each other, and therefore a star is able to maintain its spherical shape. Hotter stars like Spica, Sirius, and Rigel spend their fuel faster and have a life of a few million years, whereas cooler stars like Betelgeuse and Antares live for billions of years. After spending a few billion years of their lives and eating hydrogen, stars are now approaching their final destinations. Their fate is determined by their sizes. How? Let's have a look.
Stars can be classified into three categories according to their sizes: small, medium, and large. When small stars run out of hydrogen, their core starts shrinking, whereas they start expanding as a whole to become a red giant. Their shrinking core heats up so much that the helium atoms start fusing and forms carbon, oxygen, and nitrogen. This further heats it, and the outer layers gradually leave until what we know as a planetary nebula forms, and what remains is the core, which is turned into a white dwarf, which with time will cool down to form a black dwarf. Our Sun is expected to face the same 4 to 5 billion years from now. In the case of medium-sized stars, they swell to form red supergiants, where temperature rises to an extent that elements fuse all the way till iron. These stars explode into supernovae, which are so bright that they can outshine an entire galaxy. What is left behind is the densest object in the universe, that is, a neutron star. The case goes extreme with large stars. For them, neutron stars are also too large to exist, and their gravity forces them to keep on collapsing on themselves to form a black hole. Its gravity is so immense that even light cannot escape it. That's it. I hope you enjoyed our ride along the life of stars.